Hi, so in this video I'm going to show you how to find the area enclosed within a polar curve, and we're going to use this formula here where the area is 1/2 of the integral between alpha to beta of r squared integrated with respect to theta. So we can think about this as beta being the larger angle from the initial line and alpha being the smaller angle from the initial line to the start of a blue region. If we work out the area of all of this and then take away this area, we'll get the area which is left. Okay, so if we look at example 1, we're trying to find the enclosed area by the cardioid with the equation r equals 1 plus cos theta. So it's this region here. So from the initial line where theta equals 0 all the way round to theta equals 2 pi. So we'll have the area is equal to 1/2 of the integral between 0 and 2 pi of r squared, and we have r as 1 plus cos theta all squared integrated with respect to theta. So now the first thing we'll do is we'll expand out this bracket, so we get 1/2 times the integral between 0 to 2 pi, then we get 1 plus 2 cos theta plus cos squared theta integrated with respect to theta. So now to integrate cos squared theta, we need to use the double angle formula, where cos squared theta is equal to 1 plus cos 2 theta over 2. So I'll substitute this in place of cos squared theta. So the area will be 1/2 of our limits. Now, this 1/2 we can add to this 1, and that will give us 3 over 2 plus 2 cos theta. And then we need 1/2 of cos 2 theta. And we'll put this in brackets d theta. So now we're ready to carry out this integral. We know the integral of 3 over 2 is 3 theta over 2. And the integral of 2 cos theta is 2 sin theta. And the integral of 1/2 cos 2 theta is 1/4 sin 2 theta between the limits of 0 and 2 pi. And we're going to multiply all of this by 1/2. So now we'll substitute in our limits. Well, 3 times 2 pi over 2, the 2's will cancel, so we're left with 3 pi. The sine of 2 pi is 0, so we double that and we get 0. Similarly here, times that by 1/4 and we still get 0. So we get 3 pi minus the lower limit. Well, if theta equals 0, this is gone. Similarly, in this term, double 0, we get 0, so this is also gone. So that'd be 3 pi minus 0. So the area within the cardioid will be 3 pi over 2 units squared. Okay? Let's move on to question 2. Okay, so for example 2, we've been asked to find the exact area between the curves R1, which is this red one, and R2, which is this blue one. Rather than trying to find the entire area, we're just going to focus on this top half. So we'll find this area and then we'll double it. So to work out the top half, I'm going to split this into 2 shapes. We have this region, which we'll colour in black, and this region, which is in purple. But if we're going to do this, we need to work out the point when they both intersect. So at the intersection, we know the 2 curves are equal, so R1 will equal R2. So cos theta is equal to 1/2. Then we'll take the arc cos of both sides, so theta will be plus or minus pi over 3. So now we know that this point here is going to be pi over 3. So when we find the black area, we've got 1/2 times the integral between 0 and pi over 3. So between the initial line and the line separating the two shapes of r squared, but r is 2, so 4 d theta. And when we integrate 4 with respect to theta, we get 4 theta, times that by 1/2, and we get 2 theta. So we've got 2 theta between the limits of pi over 3 and 0. So this will give us an area of 2 pi over 3 units squared. So now we need to look at the purple area, and this will be 1/2 times the integral of 4 cos theta squared d theta. But now our limits are from pi over 3 to pi over 2. So we're looking at everything enclosed within the circle from pi over 3 to pi over 2. We can expand these brackets out and we get 16 cos squared theta. For 16, I can pull out the front to give us 8. So this will become the integral, 8 times the integral of our limits of cos squared theta, integrated with respect to theta. And to integrate cos squared theta, I need to use the double angle formula, where cos squared theta is equal to 1 plus cos 2 theta over 2. This half we can pull out in front of our integral, so we get 4 times the integral of our limits of 1 plus cos 2 theta. We'll just tidy this up and move that over to here. Okay, so when we integrate this, we get 4. The integral of 1 will be theta, and the integral of cos 2 theta will be 1/2 sin 2 theta. Between pi over 3 and pi over 2. We'll substitute in our limits. So we get pi over 2. And when we substitute pi over 2 into here, this becomes pi, and the sine of pi is 0. So this becomes just pi over 2, minus, when we substitute in pi over 3, we get pi over 3 plus 1/2 times the sine of 2 pi over 3, which is root 3 over 4. Then we'll close that bracket. We can simplify all of this, and we get 2 pi minus 3 root 3 over 3. And this is in units squared. Okay, so we have the black area, and we have the purple area. So the total area will be 2 lots of 2 pi over 3 plus 2 pi minus 3 root 3 over 3. When we work this out, we get 8 pi over 3 minus 2 root 3 units squared. Okay? Well, thank you very much for watching. I hope you found that useful. You can download the full lesson and worksheet from my website, mrmathematics.com. There's a link in the description below. Thanks again, and take care.